Hello everyone, this is Nick. We're going to talk some more about IP addresses and break them down a little bit. So now that we know about classless interdomain routing, we know that we have to have a subnet mask to identify the network portion and the host portion of an IP address. This is our IP address. This is our subnet mask. A router has to know what network packets are destined for, so it knows where to send them. I mean, that is the router's job after all, to route packets. If it didn't know what network it was destined for, it would have no idea what to do with the packet. Now I'm going to show you how a router figures out the network of an IP address using the subnet mask. And to do this, we're going to break it down into binary. Now, like I said in the previous video, there's two ways that you can read an IP address. There's one dotted decimal, which is this format. And there's binary, or base 2. Now binary only knows two numbers, a 1 and a 0, a true and a false. I mean, that's how computers work after all, right? Like I said before, the dotted decimal is made up of 4 octets. The reason they're called octets is because there's 8 binary numbers in it. Yeah, 192 can be translated to a bunch of 1s and 0s, and this is how. First, you start from the right to the left. You take the number 1, multiply it times 2. You get the number 2. Take that number, multiply it times 2. You get the number 4. Multiply that number times 2. You get 8. On and on until you get 8 numbers here. These 8 numbers is that octet. Now, I said before, binary is just 1s and 0s. So, we'll add those numbers now. Think of 1s and 0s as trues and false. 1 is true, 0 is false. Now, is there a 128 inside of 92? True, there is. Can 128 and 64 fit inside 192? Yeah, it can. That actually makes 192. Can 32 go in 192 as well? With these numbers, 64 and 128? No, because it's already 192, so we put a 0 here. That's false. And we know that the rest of these are going to be false. So that is the binary equivalent of 192. And remember, we have 4 octets, so we have to do this 4 times. 128 into 168, yep, there's a 1. Add 64, nope, that would be too high. Can we throw 32 in there? Yep, that makes 160. Can we add 16 to that? Nope, that would put us over 168. Oh, there's an 8, that makes it 168. So there's not going to be a 4, it's not going to be a 2, it's not going to be a 1, those are false. You keep doing this for the whole IP address, and that is how a computer reads an IP address. That's binary. Now we can take the subnet mask and write that out in binary. Now since it's 255, 255, 255, 255 is what all these numbers add up to. So these are all going to be true for each of those octets. So it'll look like this. And now we do something called a logical AND operation between the IP address and the subnet mask. And that will define our network address for us. Let's go back to the true or false thing. For the subnet mask, each one of these 1s is true. So that means this needs to stay the same. Each one of these 0s is false. So that means we change it to a 0. So if there's a 1 above a 0, it changes to a 0. So I don't have to write a bunch more 1s and 0s. I'm going to put the decimal version down here on the bottom. So here, everything is 1. That means everything in the IP address is going to stay the same. So 192. And just like that, we have the first octet of our network address. For the second octet, everything is 1s in the subnet mask, so all these are true. That's going to stay the same as well. 168. For our third octet, same thing. All these are going to be true. So the third octet stays the same, 3. Now here in the last octet, everything's a 0. So everything in the IP address is false. We can change all these to 0. So there's going to be 8 zeros for the network portion. And that's going to make 0. This is the network address of this IP address with this subnet mask. That's how the computer figures it out, and now you know how to. Alright, so I got a couple practice ones for us. So I put the subnet mask on the bottom and the IP address on the top. I put binary in the middle so that we can compare them. Now let's figure out which part's the network portion and which part's the host portion. Every IP address has a network portion and a host portion. This part is the network portion. This part is the host portion. You can think about it like this. The network portion is the city you live in. The host portion is your actual physical address in that city, your street address. To send a letter to you, the router doesn't just need the city, it also needs the street address. So we use Subnet Mask to define that line to let the router know where the network is and which host you are on that network. Since these are all ones down here, this part stays the same. 192.168. Since these are all zeros over here, these all turn into zeros. So, just like that, we found another network address. That's the city where 3121 lives. This /16 is called a prefix. If you count the ones in the network portion of the subnet mask, there's 16 of them. It's pretty much an easy way to display a subnet mask. /16 and 255.255.0.0 mean the same thing. Let's try another one. What's the network portion here? We got 255, 255, 255 for a subnet mask. This is our IP address up here. Our network portion is here. This is the city. Our host portion is over here. That's the actual street address. We can tell because we know that 255 makes up an octet full of ones, which means true, which means everything in the first octet of the IP address stays the same. Same thing for the second octet. And the third. Now the fourth octet, full of zeros. So we know that this part is false. This is just going to be a 0. And that is our network portion, or our network address. Over here, we got another prefix. I'm going to go ahead and show you the common prefixes. We got a /8, which is just 255.0.0.0. A /16, which we saw in the previous slide, which is 255.255.0.0. And then a /24, which is this. If you're still wondering why the subnet mask is important, let me try to explain it another way. Let's say this is your computer with an IP address 192.168.1.6. And you want to send a packet over here to this computer at 192.168.1.91. Both of these IP addresses have a /24. And we know what that subnet mask looks like. It's this one. So whenever your computer is wrapping that packet up and you put that address in there and see that it has that subnet mask, your computer knows it's in the same city. It's got the same network portion as your computer. Knowing that, all your computer has to do is open up the door and ask, who's got this address? I know it's in the same city as me. I know it's on my network. Whose computer is this? Let me change this some. So yeah, your computer knows all it has to do is open up the door and ask, whose address is this? It's on my network. So it sends out something called an ARP message. Now that stands for Address Resolution Protocol, which is something you can learn about in another one of my videos. But pretty much your computer is going to say, who has this address? The one that you're trying to send a packet to, the one that you put on the package. So it sends it out, switch forwards it. That computer says, oh yeah, that's me. So it starts communicating with that computer. Let's say instead you put the destination address of 192.168.3.64 with a /24 prefix. We know what that is. Your computer knows immediately that's not on my network. And that's why we have the default gateway. So since your computer knows that that's not on its network, it's not going to waste its time and send a ARP request. It's going to send it straight to the default gateway, which is the interface that's connecting that local area network. Then your router, it also looks at that IP address, uses the subnet mask, figures out if that's an address that's connected to it, and whenever it sees that it is, it sends an ARP message to figure out what computer has this address. This computer says, yep, that's me, and it sends it through. That is why subnet masks are very important. That is classless interdomain routing. That's how it works. I hope you learned a lot from watching my video, and thank you for watching.